Okay, hello everyone. My name is Andres Escobar, and this is activity 2 for microcontrollers. Um, the first thing we're gonna need in this program is to set the configuration bits for our for a big 16F84A. So in this case, we're going to configure our crystal oscillator as an XCT oscillator, so it would work at so it can work at 4 megahertz. And we're going to configure this in off. We're going to configure this in on. Let's go to protection. It's on, and then power up time enable bit. It's on too. Once we have established this configuration, we're going to move to the next part, that is define the frequency of the crystal is going to be 4 megahertz for a crystal oscillator. That's going to be in the peak, the microcontroller. And next we move to the ports to define the ports, the name of the ports that we're going to be using. In this case, I defined for ports A and separately for port B, because I want to be a little bit organized in order not to mess up with the ports. So in this case, we have the ports for the decoder. Well, it's going to act as a binary input of the decoder. Or microcontroller will be a program as a BCD decoder, and the port pins that's going to be the outputs that's going to be connected to the 7-segment display. In my case, I'm using a common anode 7-segment display this means that we are that in order to turn on a LED in our display, we're going to need to send a 0 or I don't know, a low signal through the port, so it would turn on the LEDs. And next thing we do is to declare a variable, an int variable called digital. There's going to be using to change between cases, and we're going to make a void here, a subroutine called display. This routine will read the value of a digital, and we change it between cases. It will display the different numbers of the different numbers in the display that is required by the ports in A, the binary signal. In the initialization of the ports we're going to use trace A or port A as input. So we declare as trace A equals 1. So it would be input. Trace B, it would be outputs. So we declare as 0. And we initialize the ports in 0. Then what we do next is to, we can do this section, this subroutine, or we can move to the main program. The first thing we do in the main program is to initialize the ports. Once we have initialized the ports, we go to the while routine or while condition, and we establish some if conditions in order to make sure that we are gonna get the number, or we're gonna establish which sequence of the inputs have to be in each one of the number. For example, for the number 0, D3, D2, D1, and D0 must be 0 in order to get the number 0, because when there's a 0 in the binary signal input, there's a 0. It's just a 0. In order to get a 1, we go to D0, it's equal to 1, and the other ones must be 0, and so on and so forth. For the truth table, this acts a lot more like a truth table, because it goes from D1 is equal to 1 and D0 is equal to 0 and the other ones is equal to 0. And when we want to make the number 3, we just added a 1 in the D0 and the other ones remains in 0. So basically this is the code that I use the routine that I use to program or to change in between each one of the conditions that the 4-dip switch will give us. So as I explained before, the subroutine display will be called anytime. Well, when a condition is it's true, the digit number, well, the variable digit would change its value to, well, to the value that it's set on each one of the conditions. So then it will call the display that this command will call this subroutine that later on will read the value of the digital, and then we change into between cases depending on the value of the digital. So if the digital is 0, it will display this configuration in the ports, and if the value is 1, it will display this configuration on the port. So you will see a number 1 in the displays. Notice that as I mentioned before, we have a common anode 7-segment display. So in order to light up the LEDs, we have to send a 0. I arranged these variables in this way so it will look more like a truth table. So we won't be confusing any value with any value of the port. Now we move on to the Proteus simulator, where we're gonna test our program. To add the file of the program in our PIC, we have to select the microcontroller. We have to click on it, and then we go to this program file. We're going to open in the icon that has a folder, and we're going to look for the program. I already looked for the program, and this is the program that the MPLab IDE builds for you, so you can use it. It's built in hexadecimal, so it will be easy to use. So once you select this program, you click on OK, and then you will start the simulation. As you can see, there's a 0 value here, the 0. So then, when I went to change this number, if our program is correct, with the bucket and we run it, and it showed no error. So in this case, this is the load, well, the less significant digit. So this must be a 1. So this is D0, this is this D0, D1, D2, and D3. And it's attached to the corresponding ports, RI0, RI1, RI2, RI3. We leave this all alone because we don't like it. So, and the second condition is to have a 2 and in this place a 2. So the third condition is to have a 3 and displays a 3. It can also display a 4, displays an 8, a 9, an 8, because we configure this to display characters from A to F, and the display whenever it can only display 1 digit. So when it's a 10, when the value here is a 10, it will display nothing. So in order to make it display something, just for fun, we wanted to display an A and a B and C and D and E, F. So in this case, it displays an E. This case displays a C. So there is the value of 12, I believe, and this value of D is for the 13, 14, and this is the 15 value. Well, the number 15. The sum up of all the binary values, we call the combinations. So we have tested our program in Proteus, so we can say that it works perfectly. Now we have to move on to the next step, which is program in our which is see the work in the physical hardware. Now we have the physical hardware here. These are the deep switch. We have deep switch of 8 ports, and we're only using 4. So D0 will be 1, and D3 will be 4. So if I change this, if I switch the one, it should display the number 1 in here. So we see that it worked. So if I want to display number 3, I have to switch 1 and 2. I want only display number 2. This is a little bit difficult with on the one hand. So it is only number 2, so it displays number 2, and we can continue with number 4. It displays an A because that is 10, and we continue with the number 3, that it's 15 because it's this 3 up, and we can return the 4 to the off position. So this becomes 4-2, and we got a 6. So as we can see, it works perfectly as expected. It was just as we expected to work. It's a 3. We're going to get a 7. So we switch the number 1, 2, and 3, and we get a 7. So this is the circuit built in with the protocol.